What is Duqu? One of the most sophisticated malware ever seen. Also known as Nextail in Stuxnet, it is a Trojan spy, information stealer rootkits. This is extremely similar to the Stuxnet worm in terms of design philosophy, internal structure and mechanisms, and implementation details. This malware targeted the Windows-based computers. Its main purpose was gathering information of an organization, useful for later attacks. Malware collects and forwards the confidential information from the system to a remote command and control server. This can be found as two versions. Duqu, 2011. Duqu, 2.0, 2014. There are no confirmed details about malware writers, but believe the same team who developed Stuxnet or a group that has access to the Stuxnet source code should be responsible for that. Basically, the malware targets some specific organizations related to the manufacturing of industrial control systems, to take remote access to their computers and gather information by information stealer components. Mostly Western countries, as well as Asian and Middle East countries, were targeted by the malware. Especially, some of the new 2014 to 2015 infections are linked to the P5+1 events and venues related to the negotiations with Iran about a nuclear deal. In addition to the P5+1 events, this malware group has launched a similar attack in relation to the 70th anniversary event of the liberation of Auschwitz-Birkenau. This image shows the 15 different variants discovered around the world. It's a rootkit to hide its activities, and also it has the ability to bypass few anti-malware products. Also used a system driver, which was digitally signed using a stolen certificate. It has the ability to remove from the system by itself or extend its lifetime according to the attacker's commands, but default malware has 30 days life cycle. This illustration shows the initial installation process of the malware on a targeted system. Let's check some further details on this process. The first step. This malware arrived at the target using a specially crafted, Microsoft Word document. The Word document contained a currently undisclosed zero-day kernel exploit that allows the attackers to install Duqu onto the computer unbeknownst to the user. Let's talk about the exploit that malware used to initiate on a system. This exploit allowed the attackers to jump directly into kernel mode from a Word document, a very powerful, extremely rare. In Duqu case, they have used this to execute arbitrary code on the target machine. When the Word document is opened, the exploit is triggered. It loads the shell code from Word document as a kernel mode execution gained by exploit. Technically, the vulnerability that used on this case is known as CVE 2011-3402, but non-technically it is true type font parsing vulnerability. This is unspecified vulnerability in the true type font parsing engine in Win32k in the kernel mode drivers in Microsoft Windows operating systems, allows remote attackers to execute arbitrary code via crafted font data in a Word document or web page. After the initial exploitation, the shell code on the Word doc will be executed on the system as kernel mode execution. This shell code will first check if the computer is already compromised by looking for the registry value. If the computer has already been compromised, the shell code gracefully exits. If the computer has not been infected, the shell code decrypts two executable files from within the Word document: a driver file and installer DLL file. The shell code then passes execution to the extracted driver file, and finally, the shell code will replace itself with zeros, wiping itself from memory. After the shell code passes the execution to driver file, it injects code into services.exe, as defined by the installer configuration file. After that installer gets the execution chance on the system. The installer proceeds to decrypt 3 files from within itself. Malware's main DLL. System driver file, that is the load point that starts the malware after a reboot. And a installer configuration file. The main DLL and driver file are the only components that will be left on the system after installation has completed, along with the different configuration files. Let's talk about the installer. The installer configuration file has 2 timestamps inside representing the time frame window for installation. The installer will terminate if executed outside this time window. If the date falls within the time frame, the installer DLL then passes execution to Duqu's main DLL by hooking anti-DLL file in the same manner as Stuxnet. Installation continues from inside Duqu's main DLL. The main DLL component has 8 exports. These exports can perform 8 different tasks on system. Export 1. Initialize the data. Export 2. Run export number. Export 3. Get the version information from the configuration data. Export 4. Inject itself into a suitable process and run export 5, only if on a 32-bit platform. Export 5. System setup. It has 2 parts. 1. Pre-install, drop the provided load point driver and create service. 2. Post-install, load the resource 302 DLL, resource 302 is a loader for the main payload. Export 6. Cleanup routine. Export 7. Start the RPC component. Export 8. The same as export 1, but with a delay time. Among these exports only 4 and 5 are important to the initial installation process. So let's find out more information on those functions. Export 4 is responsible for finding an appropriate process to inject into, injecting the main DLL itself into this process and passing along a pointer to the 3 decrypted files. Export 5 is the actual installation routine. Export 5 drops the load point driver into the highlighted directory path in video with a name defined by the installation configuration file. Next, a service is created so the driver is loaded every time Windows starts. The main DLL is encrypted and placed in the location that highlighted in the video with a name defined by the installation configuration file. This file will be decrypted and executed by the driver when the computer starts. The final step of the installation phase involves the main DLL reading a configuration file from within itself, encrypting it, and placing it in the same folder as well. When the installation phase is completed, there are just 3 files left on the disk: the driver, the encrypted main DLL, which will be decrypted by the driver, and the encrypted main DLL configuration file. Now Duqu is installed. During the entire process, every part of Duqu resides decrypted only in memory. Only one unencrypted file, the load point driver, is ever written to the disk during the entire process. The following animation will demonstrate that. When malware decrypting its components, the encrypted component will be loaded to the memory and decrypted by the main DLL, and decrypted data will remains the memory. They will not written back to the hard drive. So there will be no any decrypted component on hard drive. Only one unencrypted file, the load point driver, is ever written to the disk during the entire process. Duqu was clearly designed to minimize detectable footprints left on the disk. After that, the threat begins execution at system start through a registered driver. Same as load point driver. In different variants, this driver may be different. So it could be one of the following files: JMINET7, CMI4432. This is a stolen certificate image that used that malware to register the load point driver as a valid driver on a target system. After the load point driver load to the system and bind to a newly created service, it will be able to automatically invoked when the computer starts on. After this process is done, driver file injects the main DLL into services.exe. Using the configuration file, the main DLL extracts an embedded file. Resource 302. Resource 302 is a DLL that contains another embedded section, .zdata, that contains the main functionality of the threat. Resource 302. The .zdata section inside resource 302.dll. This is the payload of the threat. The purpose of the .zdata DLL is command and control functionality, which allows downloading and executing updates and additional payload modules. Using this functionality, malware will able to communicate with C&C servers and continue the attack. Duqu uses special custom command and control protocol over the existing protocols, and using those features it will able to communicate using the following methods. Encapsulated in HTTP over port 80. Encapsulated in HTTP over port 80 using a proxy, may be authenticated directly over port 443. Encapsulated in HTTPS over port 443. Encapsulated in SMB primarily for peer-to-peer command and control. The Duqu custom command and control protocol is a reliable transport protocol, similar in features to TCP. The command and control protocol implements fragmentation, reordering, and handles duplicate and missing packets via sequence and ACK numbers. Let's discuss about Command and Control Center. The command and control functionality can download new executables and either execute them directly in memory or write them to disk. When written to disk, they are saved encrypted using a file name defined in the configuration data. When using HTTP, the client sends repeated GET requests to the server. The server replies with modules to execute. To return data, Duqu uses a POST and sends a small blank JPG file appended with the data to send to the server. When using HTTPS, the same happens, except within an encrypted HTTPS session. The HTTP and HTTPS protocol only encapsulate another Duqu specific custom protocol. This is a comparison of two downloaded threats by malware that provided by an attacker through C&C server. InfoStealer 1. This is a standalone executable. It can collect data of list of running processes, account details, and domain information. Drive names and information including those of shared drives. Take a screenshot. Network information, interfaces, routing tables, shares list, etc. Keylogger. Window enumeration. Share enumeration. File exploration on all drives, including removable drives. Enumerate computers on the domain through net server enum. InfoStealer 2. It has less features than above one. This is a standalone executable. It can collect data of list of running processes, plus account and domain. List drive names and information, including shared drives. Screenshot. Network information, interfaces, routing tables, and shares list. Windows enumeration. Share enumeration. Share browse. So using these kinds of modules, Duqu can collect and send information to the attacker while living in shadows. Spread across the network. It doesn't do the self-replication to spread over the network. But it also can to be spread to another target only if the attacker wants to do so. That means if the Duqu gets a command from CNC server to clone to another target host only, then it will clone itself and send to the target PC. This newly created copy will also be initiated as we discussed on earlier, but there is one special thing on this case: newly created malware doesn't connect to CNC directly. It communicates with CNC through the parent malware. Below illustration will demonstrate this. All the details which we are mentioned in this video are related to the Duqu 2011 version, version 1. There is another Duqu version called Duqu 2.0. In the year 2014. There was second attack based on Kaspersky company. This is also similar to Duqu 2011 attack. In new version there were 3 zero-day attacks. CVE 2015-2360. CVE 2014-4148. CVE 2014-6324. In here they will inject malicious code into the msiexec.exe. They use their own custom object-oriented framework to doing this attack, which is using C language.